Let's practice doing some higher order derivatives given some explicit functions. Our first function is f of x equals 3 times x to the 5/3, and we want to find the fourth derivative. So the way we're going to do this is we're going to take four derivatives. Our first derivative by the power rule is we bring down the power, we multiply it by the coefficient out front, and we subtract 1 from the power. So it was 5/3, taking 1 away is 2/3. That leaves us with 5x to the 2/3. Our second derivative, we do the same process. We bring down the power to the front, we multiply by the coefficient in front, but we subtract again. 2/3 minus 1 is -1/3. So this leaves us with 10/3 x to the -1/3. For the third derivative, we do the same process again. We bring down the power, -1/3 times 10/3 x to the -4/3. This leaves us with -10/9 x to the -4/3. And finally, for the fourth derivative, we bring down the power, -4/3, multiply by -10/9, subtract 1 from the power again, -7/3, we are left with 40/27 x to the -7/3. And that's how you do the fourth derivative on that. It's just keep going. The next one's a little more complicated. So if this is, we'll say y equals, then y prime, well, now we're going to need to do a product rule. So I need to take the derivative of this, which is 1, times sine, leave sine alone, plus x times the derivative of sine. So that's cosine of x. So that leaves me with sine x plus x cosine of x. So for y double prime, I need to take this derivative, which is cosine of x, plus, now I need to do a product rule here, so I do 1 cosine of x plus x negative sine of x, which gets me 2 cosine of x minus x sine of x. Okay, so then we do a third derivative. So the derivative of cosine is negative sine, so -2 sine of x. But we have this negative x sine x. Now what's interesting is that's our original function, right? Except there's a negative in front. So we don't have to take this derivative. We could do it, but we already know what the derivative of just this piece is. It's this. So we can just say minus sine of x plus x cosine of x. So that leaves us with -3 sine of x minus x cosine of x. And so now if we take the fourth derivative, the derivative of sine is positive cosine. And then we have this x cosine x. Well, we know what that derivative is because, well, we kind of do. Let's go ahead and just do it. We could piece it out from this, but let's just go ahead and do it. So we'll do minus 1 cosine x, and then minus x negative sine of x. So what you find is you end up with minus 4 cosine of x plus x sine of x. So do you notice anything here, by the way? Notice that at each derivative you have a sine or a cosine. So you have 1 sine x, 2 cosine x, negative 3 sine x, negative 4 cosine x. So it's going sine, cosine, and then 1, 2, 3, 4, and then the negatives are coming, and you'll see they will alternate as time goes on. And then on each term you have x cosine, x sine, x cosine, x sine, and they're also doing an alternation, but it's sort of lagging behind. And so, or actually I guess it's out ahead. But so you'll notice that that's actually going to persist as you go on. If you did more derivatives, you're going to see that type of behavior. It's actually really interesting. But anyway, for this, what we're going to have to do is we're going to have to do a quotient rule. So if we call this y, then we're going to have to say dy dx is, we're going to say low derivative of high, low d high, minus high d low, so derivative of low, or the derivative of the denominator, which is 1, over low, low. So that's x minus 10 minus x minus 10 squared, which is negative 10 over x minus 10 squared. So negative 10 over x minus 10 squared. So now we need d2y dx squared. So we have to say low x minus 10 squared d high, which is 0, because that's 0, minus high d low. Now, we don't have the tools right now to do this derivative as it looks like. We're going to learn those tools. So since we don't have those tools right now, we're going to have to do the annoying thing. We're going to have to multiply this out. X minus 10 squared is x squared minus 20x plus 100. So the derivative is 2x minus 20, or 2x minus 10, and that's the way I'm going to write it. So 2x minus 10 over x minus 10 squared squared. So then that becomes 0. That becomes positive 20. So it becomes 20 x minus 10 over x minus 10 to the 4th, which then becomes 20 over x minus 10 to the 3rd. So what's neat is we're going to learn some tricks in the upcoming sections that make solving this way, way faster. We can really use some neat tricks that save us some time and keep us from having to do a whole lot of extra work. One extra algebraic trick, if you're interested, for this that makes your life a little easier, especially going forward, is right, x is equal to x minus 10 plus 10. Of course it is, right? That's just 0. So then you can cheat and you can bring this out into x minus 10 over x minus 10 plus 10 over x minus 10, which is equal to 1 plus 10 over x minus 10. Now, why would we want to do that? We would want to do that because when we take a derivative, we know that that's going to be 0, and we know that taking the derivative of this is going to be easier than this, because in this case I have a constant on top, so it's going to make one of those things 0. But even more than that, as we move into what's called the chain rule, this is going to make doing a chain rule much, much better than having to do a quotient rule.